Hello, I'm glad you could join us today for our frog dissection. During your life science study this year, you've had the opportunity to learn a great deal about a number of different organ systems, all of them being essential for life. Today, I'm going to demonstrate in particular the frog dissection. You will be able to examine different organ systems firsthand, up close. You'll be able to see what the interrelationships between those organ systems are, and you will be able to study particular organs in great detail. The frog is conveniently a vertebrate that has many body structures in positions and arrangements similar to ours. The bullfrog that we're going to dissect is preferably larger than most other types of frogs, and it is in no way in any kind of a population shortage. We will now take a look at the tools we will use during our dissection. Our ruler will allow us to measure particular parts of our specimen. Scissors will prove to be very helpful in opening and cutting any skin that we run into. Tweezers will allow us to pick out particular organs or parts of our specimen for closer examination. Our dropper will lend itself to collecting any excess liquid we run into during our dissection. Pins serve to keep our specimen fastened closely and tightly to the dissection tray. This will cause the frog to stay secure and not slide during dissection. The scalpel allows us to cut through anything that our scissors will not allow us to. Bone is an example of this. And finally, the dissection tray is where our dissection will occur. Now let's do an external examination of our specimen. While doing this, we want to keep several terms in mind. They are: the anterior end of our specimen is the head end. The posterior end of our specimen is the tail or opposite end. The dorsal side of our specimen is the top or the back side of our frog. And finally, the ventral side of our specimen is the belly or the stomach side. In review: anterior end, posterior end, dorsal side, ventral side. At first glance, our specimen may look quite ordinary, but after further review, you'll notice several characteristics that are unique to our amphibian. First, let's take a look at our specimen's skin. We find the skin to be loose and moist, very similar to the way the skin would appear in the frog's natural environment. As we look closer, we can see very fine blood vessels running just beneath the skin's surface. A frog partly breathes through its blood vessels located near its skin, and this is a very good reason why they're mostly found living near wet and moist places. We will now examine the legs of our specimen. As we compare the anterior legs to the posterior legs, we notice that this specimen has evolved specific uses for each. The short anterior legs allow the frog to do several things. They provide a safe landing after a long jump, and they are also conveniently located near the mouth for quick shovel-like feeding motions. The posterior legs are indeed used for locomotion. The long muscles allow for great springing action on land during jumps, and the webbed toes allow this frog to swim quickly and effectively. As you can see, our specimen is highly mobile, both on land and water. Now let's examine our specimen's eyes. A frog's eyes are located on the dorsal side of the specimen. This allows the frog to be completely submerged in water and still view what is going on around it. This is an excellent tool for both hunting and escaping. Now let's look a little closer and let's examine the eyelids that protect the eye of our specimen. As we examine the eyelids of our frog more closely, we can see that by pulling back the upper eyelid, we get a clear look at the bottom eyelid. This line represents the top of the bottom eyelid. In between, we see the third transparent eyelid that protects the eyeball of our specimen. This transparent eyelid is used primarily when the frog is underwater. It covers the eye and works similar to the way a pair of goggles would work on you while swimming. This serves as protection for the eyeball. Now let's examine the ears of our specimen. A frog's eardrums are actually located on the outside of its body, unlike you and I, who have eardrums that are located inside of our head. The eardrums pick up sound vibrations that pass by the frog. These messages are sent down a very fine, thin canal. Nerves pick up the messages from there and communicate them to the brain. This all happens very fast and allows the frog to act on stimulus from the environment. Now let's examine the tongue and teeth of our specimen. As we open our frog's mouth, we notice that the tongue is attached to the front of the frog's mouth. On the other side of the tongue, we find a forked shape. This is the end of the tongue that leaves the frog's mouth and has a sticky substance on it that traps prey. Almost as quickly as the frog's tongue has left the mouth, it recoils back into the mouth with the prey securely in hand. Any teeth found in the frog's mouth are used to secure or hold its prey, not to attack or catch it. The two largest teeth are found on the roof of our specimen's mouth. We have now completed the external examination of our frog, and we're ready to begin the internal examination part of our dissection. We are now going to pin the skin of our specimen. We need to keep in mind that a very important organ of the frog is its skin. Not a lot of people view the skin as being an organ, yet the frog is very dependent on this for life. To pin the skin, we will need to cut in a T-like formation from the anus area up through the middle of the frog and then make a T shape toward the top. Because of the amount of room that I have to work with, I have made a decision to clip off the skin instead of pinning it to the dissection tray. I now have a very clear look at the interior anatomy of my specimen. I will continue to cut toward the mouth to get some of the more hard to reach organs and organ systems into view. At this point, it might prove to be beneficial to use the scalpel if you're having a great difficulty cutting through, as this breast area of the frog is much tougher than the abdominal area. Again, I want to do everything I can to avoid cutting too deep.
To better understand the organs and their relationships, we use this animation of the frog's digestive system. When food enters the frog's mouth, it first travels down the esophagus or gullet. This curved organ is the frog's stomach. Food begins digestion here. The frog has 3 livers that excrete digestive juices and bile into the gall bladder. From the stomach, the food passes into the small intestine where 2 organs, the gall bladder and the pancreas, work together to produce digestive juices. These juices aid in the extraction of nutrients while the food passes through the small intestine. From the small intestine, the food travels to the large intestine. The kidney extracts contaminants from the frog's blood and concentrates these contaminants in urine. The urine is stored in the urinary bladder until excreted out of the frog.
When you're ready. The first system that we will take a look at is the digestive system. It obviously begins in the mouth with the teeth and the tongue, but the first area in which food is passed is the gullet. The gullet is buried beneath several organs which are in view right here. The gullet can be viewed as the link between the mouth and the rest of the digestive system. From the gullet, food passes through into the stomach area, in which you can examine the livers play an important role. The frog, which has several livers, uses these to add digestive juices to the food being sent through the digestive system. Enzymes in these juices help break down a variety of different foods the frog may ingest. Like us, the livers of the frog are its largest organs. As we re-examine the stomach, we find it is long and tube-like, and when brought out, runs in a banana-like curve. This is where most digestion in a frog occurs. And as we poke at the stomach, we find it is a very coarse, hard organ designed to digest a variety of foods. As food leaves the stomach, it gets sent to the small intestine. The small intestine heads back up and in a series of turns and twists. The reason for this is that the small intestine is very long and it would not fit within the frog if it were not coiled and turned. From the small intestine, food that is being digested goes to the large intestine. The diameter and the width of this tube fatten as we move towards the anus. Often when we open up this particular organ, we find digested wastes ready to leave the frog's body. From here, we travel downward towards the anus where digestive foods leave. The next system that we will examine will be the circulatory system. The circulatory system doesn't have as wide a variety of organs that are part of it. It consists of the many blood vessels that we've seen in many different areas in the frog, and its primary organ is the heart, or the pump for the circulatory system. In order to get a better view of the heart, we're definitely going to have to remove the livers. And while doing this, we will open one of them so you can get an internal view of what the inside of one of the livers looks like. Like most organs, the liver retains a lot of water. When removing the livers, be very important not to damage any other organs that might be nearby, the heart or the lungs, which are located immediately and directly beneath. Always keep in mind, it's better to be slow than fast. And finally, so we can get a real clear view of what lies beneath these large livers, I'll remove the third. And then I will give you a cross-section look. As you can see, it looks very similar to the exterior area of the liver organ, yet we find very fine, small passageways within the liver. Now that we've eliminated the liver, the gallbladder comes into clear view. The gallbladder's purpose is to store bile from the liver. It then gives this bile to the intestines as they need it. It is sac-like, and at closer examination, we can see that blood vessels also run through this organ. Now we want to more closely examine the part of the circulatory system that we set out to isolate, the heart. This will be best examined if we can cut it away from the other area and the other organs in which it is situated. By getting underneath, this task is much easier. When examining the heart, we need to keep in mind three primary areas: the right auricle, the left auricle, and the ventricle. The right auricle collects blood from all areas in the body. The left auricle collects blood from the lungs. Both auricles contract and send the blood that they are holding to the ventricle. The ventricle then contracts and sends blood to all areas of the frog's body. Now let's see if we can actually take apart the different sections of the heart. First, I will cut diagonally and separate the auricles from the ventricle. This is complicated and does not always work. At closer examination, we can see the connection between the auricles and the ventricle. Although we are unable to see the actual differences in the two chambers, we can see the larger tubes that bring blood in and out of the heart. We should keep in mind also that the heart is a very effective muscle. And as we go down toward the ventricle end of the heart, we notice a mass amount of muscle tissue. Keeping in mind the area in which the heart used to be, the lungs are advantageously positioned. Both may not appear to be the same size due to the fact that the frog's left lung will be competing for space with the beginning part of its stomach. The frog, unlike us, breathes a large amount of its oxygen and carbon dioxide through its skin. The mouth proves to be as effective or more effective in oxygen intake and carbon dioxide release as a lung. The skin and blood vessels are a very integral part of the frog's respiratory system. At closer examination, we can see that the lung is truly an air sac. Now we can examine another system, the reproductive system. In order to be able to do this, though, we need to eliminate the stomach as well as the intestine. This should be rather easy if you can effectively cut one end and go from there. Once again, we see the importance of the complicated system of blood vessels that intertwine themselves around every organ in our organism. This task can prove tedious, but it's very important to be able to view what still lies closer to the dorsal side of our organism. I now have removed all of the intestine as well as the stomach. We do have a clear view of what remains in our organism. I can tell that this is a male bullfrog. A couple characteristics give this away. First of all, on our male, we notice two testes, one to the right, one to the left. On the exterior observation of our frog, we notice an enlarged thumb pad. Some of the other organs that you see nearby are fat bodies. Much like you and I, the frog stores excess glucose and nutrients as fat bodies. If we were to remove, like we shortly will, the testes and the fat bodies, we'll get a closer look at the kidneys. In clear vision are now the kidneys. To the lower end or posterior end of our frog, we notice two more sac-like organs. These are the urinary bladder. At closer examination, we start to get a real feel for the diet of our frog. It is appearing to us as if it was in the midst of digesting some sort of a crab-like organism. This ends our frog dissection for today. Thank you for joining us.